Hello, welcome back to Cracking the Cryptic, and a puzzle inspired by Phistomefel apparently today. We will see, well, I don't know if we will see why, but we might see why. It's by Kenneth's dad, who's been a really consistent constructor for some time now, and I look forward to their puzzles. I mean, they're really good. So we'll check that out in a moment. There's some rules that you need to be a little careful about understanding, I think. That's happened a few times lately. Yeah, I mean, people who comment occasionally that the rules are really badly expressed, I'm not sure they've ever created a rule set and tried to express rules before, because it's very easy for them to be misunderstood. And what I do recommend is that you watch the bit of the video where I explain the rules. There are chapter headings. Anyway, that's a general point, not about this puzzle particularly. What I will say is that in our apps, it takes very little time to understand the rules. In almost all of them, they are generally repeating the same types of rule, like in arrow Sudoku. It's largely just arrows. And in Domino Sudoku, you get used to the crop key dots and the X's and V's quite quickly. So they are great resources for testing your Sudoku skills, to be honest. You can check out all of the apps on the links under the video, including our latest Approachable Sudoku. And I think you'll find them very much up your street. The puzzles are by some of the best constructors in the world, always, and we recommend them highly. Also, coming up on the 1st of September on Patreon, a new hunt, the Hollywood Lunchbox. A bunch of sandwich Sudokus of various sorts. They're not all standard sandwiches at all. And that is probably the point in a lunchbox. You want a variety. Well, I do. Anyway, that is coming up on the 1st on Patreon, along with all of the other content we have on Patreon. Do check out the connections videos, the crossword videos, extra Sudoku, packs, and all sorts. It's great stuff. And 600k Bang by Rockrat Zero. I recommend that especially. It's great fun. Very good use of time. And what else we got on the links under the video? We've got Sven's Sudoku Pad, a marvellous resource, of course. And we've got our merchandise, so do check it all out. Just looking around for merch. I haven't got any here. But it's great stuff, and we recommend it highly, obviously. Now, the first link under the video is to Spread by Kenneth's dad, and the rules are as follows. Normal Sudoku rules apply, so we're going to put 1 to 9 in every row, that's not a column, every column, and every 3 by 3 box. The sum of digits along a line between two circles is equal to the sum of the digits in those two circles. These are double arrows, apparently. So the lines are all very short here. That cell is equal to the sum of those two. It's a bit like a sort of arrows puzzle in some ways, but the arrows are messed around with. Now, an X in the center of a 2 by 2 region of cells is a product square, indicating that the 2 digits in the square's positive diagonal have the same product as the 2 digits in its negative diagonal. So multiply those two together, you get the same answer as for those two. The product's not necessarily the same for different product squares. Surprise, surprise. And not all product squares are necessarily indicated. There's no negative constraint. Yeah, okay, I think I know which puzzle this is inspired by. Simon did a Phistomefel not long ago, which had these little 2 by 2s with dots in. Was it the one with the rhyming name? Fare thee well, Miss Carousel. I'm not even sure. Check it out. I'm not sure if it was that one, but there was some sort of... Was there a product relationship or a sum relationship between the diagonals? I thought it was a sum relationship. That's why we have X's this time, for the product relationship, I suppose. Anyway, if it's inspired by Phistomefel, it can't half be bad, perhaps. Let's... Sorry. Let's restart and say, let's get cracking. So, there's no given digits, nothing to get. I think in the Phistomefel puzzle, it benefited Simon hugely to do some thinking about the nature of these X's, of the 2x2s. Well, I don't see what else I can possibly do, I have to say. What's going on? There's a lot. No, there aren't. There are a few here and here and here. I'm finding, and they're overlapping. Okay, I'm finding 2x2s in which 3 of the cells are joined by one of the double arrows. So, yeah, let's think about the possibilities for one of these 2x2s. So I'm just going to highlight this 2x2. And then if I can come up with a general principle, it might be good to extend it down here. Okay, what can these be? Because that is going to be the sum of those two, but also the contributor to a multiplication that leads to the product of them. And actually that's not simple. Okay, I mean, I might have to literally run through in order, maybe until I figure out what can happen. The possible, the good thing about these digits is they can't be more than adding up to 9 to allow that cell to exist. And I think as we get up to the higher numbers, it's going to be clearly impossible. So I'm going to start at the lower numbers and see if there are possibilities. We have to remember these two could be the same. But if they were 1 and 1, the product would only be 1. And once you put 2 there, that's broken. If they were 1 and 2... Oh, hang on. If they were 1 and anything, the product here is... or the sum here is going to be a higher number than the anything. So x times 1 is x. I'm using x as a variable, not the x in the center of the 2x2. X times 1 is x, but x plus 1 is more than x. And more than x cannot multiply with something else to give x. So that's algebra, but I mean, I'm sure you'll understand that more basically than with an algebraic formula. There's no 1 in these circles. Okay, well that is a big step forward because now the number of combinations that have to give a sum of 9 or less is dramatically reduced. So let's start with 2 and 2. Now that does work, annoyingly. If that was 2 and 2, this would be 4, and that would be 1, because 2 times 2 is 4. I've never told you a sum so basic as that before on the channel. And 1 times 4 is 4. Now I have. Right, so 2 and 2 work. 2 and 3 don't, because they sum to 5, and that's not in... that can't form a product of 6 with anything else. 2 and 4 would give 8 here. Yeah, that does work. And that would give a 1 here. No, it doesn't give 8 here. It gives 6 here. 2 and 4 have a product of 8, but a sum of 6. I can't do the simplest sums now myself, having mocked myself for telling you simple sums. Right, so it's not 2 and 4. 2 and 5 would give 7 there. That's not going to contribute to a product of 10. 2 and 6... 12 would give an 8 here. That doesn't work. 2 and 7 would give 9 here. That's not going to work. Wow. So if there's a 2 in one of them, there's a 2 in the other, a 4 here and a 1 here. Okay, I am going to mark these as candidates because if 3 is... I can't believe it's going to get easier with other digits. So let's start... We've done 2 and 3 already, so we'll start with 3 and 3. Oh, well, that does work as well. 3 and 3, 3 times... No, hang on. It doesn't. 3 times 3 is 9. But 3 plus 3 is 6, which doesn't have a product of 9. I am finding it hard to do this. Anyway, 3 times 4 is 12, but 3 plus 4 is 7. That's no good. 3 times 5 is 15. 8 is no use to a product of 15. 3 times 6, well, that does work, and they're different. 3 times 6 gives a 9 here and a 2 here. 18 being the product. Okay, now I move on to 4s, because I got up to 9. And we've done 4 times 2 and 4 times 3. So I've only got 4 times 4 and 4 times 5, which I know doesn't work, left. 4 times 4, oh, bother, that does work. 4 times 4 is 16. That would give an 8 here and a 2 here. Okay, so what we've learned is that the number in the crook of this X with a double arrow on is 1 or 2. And we've got that again here in this 2 by 2. And now we've got it here. That is 1 or 2. But also this one is in the crook of another one. So that's 1 or 2. That gives us a pair. That's why I was getting excited. No, I am right to get excited, because in this 2 by 2, in the yellow 2 by 2, this digit is one of these circles. These are the only ways these can work. In fact, I ought to write those into all of these to start with. 4, 8, or 9 on the bend of the double arrow. This is getting quite interesting now. I mean, in the sense that I might be able to make some progress. Now, this is an overlap. It has to both be from 1 and 2 and from 2, 3, 4, and 6. So that's a 2. And 2 always went with the number 2. That puts a 4 here and a 1 there, and we're away. I've got some digits in the puzzle. Yes. Right, now, these can't be 2s anymore. So the possibilities are 3, 6 or 4, 4. So this is not a 4 now. This is 8 or 9. Now, it can't be 4, 4 because that 4's looking there. Right, so that's a 3, 6 pair with a 9 there. Now, this one can't be a 9 by Sudoku, so it's not a 3, 6 pair. So these are the same. They're either 2, 2 or 4, 4. And now one of these is a 2, because if that's 4, 4, that's a 2. If that's 2, 2, that's a 2. So this is not a 2. And they always went in pairs. They went hunting in pairs. So those can't be 2s now. This is either a 3, 6 pair with 9 and 2, or a 4, 4 pair with 8 and 2. So that's always 2 in the blue. I think this logic is right. I was going to look at this. This is reminding me of the Phistomefel puzzle, where the absolute trap, in my opinion, was that one of his 2 by 2 squares didn't have a dot in the middle, but you got so used to considering the geometry that you imagined a dot in the middle. I'm very quickly imagining an X in the middle of this 2 by 2, but there isn't one. So this is just saying that plus that equals that. I thought I could get away from this point maybe with just Sudoku, actually. So it just doesn't matter. We've looked at all of the X's in the middle of. I mean, there are more X's, but they're not really affected by the double arrows. So what do I do next? It's a very interesting puzzle. I tell you what, that digit, where does that go in box 5? Because it's either 1 or 2, which appears in row 6 in box 4, so it's got to be there in box 5, whatever that is. And now, again, one of these is a 2, because one of those is a 2. Or, oh, hang on, is it true that one of these is a 4? I haven't trimmed this down, have I? 3 and 6 in those gives a 9 here. 4 and 4 in those gives an 8 here. So this is not a 4. Oh, bother. I thought I was going to say, if I could have said that one of these was definitely a 4, that would have solved this. But no, 8 or 9 there. Now, if it's a 9, that's a 9. Probably Sudoku is not my friend yet in this puzzle. I have a feeling there's a lot more to do first. One of these is a 2. Oh, okay. There are certain places in this puzzle where we can't put 1 and 2 in the circles. And these 3 circles are amongst those. But this, which is the sum of those 2, can't be a 9. So the digits here are either 3, 4 or 3, 5. They definitely include a 3, and this is 7 or 8. Now the fact that they definitely include a 3 makes this a 6, and that makes this a 3. And does that carry forward anywhere? Not quite, but I'll tell you what it does do. It puts 3 in box 6 into this 2 by 2. Now it can't be here because that's not lower. So it's in one of the circles. One of the circles has a 3. If it was this circle, then we're looking at a 7 definitely here. Now what would that do in the middle row? 3, 7, 9, 6, 8, therefore 5. Yeah, okay, that would work all right. Pity, because otherwise I could have ruled 3 out of there. I mean, I could also consider where 1 and 2 go in this box, because if they don't both go there, one of them has to be in one of these cells, and it's not here. It would have to be here. It's almost useful. In the category of almost, I think. Oh, I've got a 4 on this X. So if this is a 1, that won't work. These would both have to be 1, 4 or 2, 2, and it's just impossible. If this was a 2, these would have to multiply up to 8. They would be 1 and 8. That is definitely possible. If this can't be a 3. If it was a 4, these would be 8 and 2, but neither of them can be 2 because of these 2's. So 4 won't work. If it was a 5, we're looking at a 20 sum. And yeah, that's a general principle. You can't have a 5 in one of these 2 by 2's because the other diagonal would need a 5 in. 4 and 6, oh, that would work. 4 and 6 is 24, which could be 8 by 3 on the other diagonal. You do need to find multiplications that use different digits. They can use the same digit in the same multiplication. Right, 4 and 7 won't work for the same reason as 5 won't work. 4 and 8 would be 32, but that would have to be 4 and 8. 4 and 9 is not possible by Sudoku, otherwise it would have been. So if this was 4 and 2, sorry, I filled in these in case this was 4 and 6. If it was 4 and 2, these are 1 and 8 in some order. Right, well this digit now is 1 or 8, but on this double arrow it can't be 1, so that's an 8. This now can't be 8. This is a 5 by maths. Well, maybe I can do the same again here, because these are operating in one of 2 pairs. This is either a 1 with a 2 here, or a 3 with a 6 here. And that means there's a 2-to-1 ratio between those. And I think that means there must be a 2-to-1 ratio down here, but I don't know, maybe that's not the place to do my next bit of work. That 5, no, it's not helpful quite, but it puts 5 in one of those 2 places. Now, where's 5 in the middle row? It could be there. then this would go 5, 8, 6, 9, 4, 2, 1. This would have to be 3 and 7 with a 4 there. That is possible. But otherwise, 5's in this pair. Now, if 5 was there, again, this would have to be 5, 8. And that does work. 4, 2, 1, 3, 7. Okay, well, now what I'm thinking is 5 and 7. I don't think 5 can be here. This is my point, actually. Because this would be a 2, but I think we've worked out that one of these is a 2, and that means one of these is a 2. I don't know. I worked out that one of those is a 2. Is it definitely true for one? This is either 2 and 2 with 4 and 1, or it's 4 and 4 with 8 and 2. No, and in that case, one of those wouldn't be a 2. Oh, well, maybe let's think about if this was an 8. That would be a 7. This wouldn't be a 5. So there would be a 5 here. So if that's 8, with this being 4, then there is a 5 in one of these two. It can't be here anymore, because that can't be 9 and that couldn't be 3 in that. No, this couldn't be 9 or 8. Right, if that was 8, this is 4. This can't be 5, because that can't be 8 or 9. This could be 5 if that was 3 and that was 2. And that would be 1. It doesn't quite break. It's so cunning. Oh, I bet there's some really easy place you've been shouting at me for ages to look at. Oh, I'll tell you what, by Sudoku there's a 2 on that X. I mean, that's not going to do anything yet. But I have just noticed it. I know there's a 3 in those circles. I don't think I was using that here. It doesn't matter. There's a 5 or 7 there and a 5 or 7 there, and that's really interesting, but I don't know why. 3, 9, 5. Oh, this is, I'm sure one of these breaks quite easily, and actually then probably the whole puzzle will finish. I think it's going to get a lot easier if I can just get the next step. But I don't know what it is, so I'm going to have to go through these same thinkings again. Oh, blow. Okay, these two are on an X, and they can't be 2, 4, 5, or 8. So the available digits are 1, 3, 6, 7, and 9. 7 is not ever on an X. So we've only got 1, 3, 6, and 9. So one of these is divisible by 3. And that means that... it doesn't mean that one of these is divisible by 3. But it means that somewhere in this 2 by 2 there's another digit divisible by 3. That's not as interesting. Oh, this is definitely a different rule set from ones I've done before. Obviously. This is 4, 5, 6, or 7 because of what it sees. And then these are all less than those. I've just got to think about this 2 by 2 again and again. Right, let's say this was 4 by 4, which has to be the more constrained version, which puts 8 there and 2 there. And that becomes a 2. So yeah, so one of these is always a 2. That's true. And therefore this can never be a 2. Now, it can't be a 1, I don't think. Now I'm not sure about that. I thought in my head, I haven't mentioned this, but I thought in my head I'd ruled out 1 from here. That would be very interesting. Where can 1 go in this row? Either there or there. If it goes here, it's got to be a 3 there, because we've said 3 is in one of those cells. Then that would be a 4, and these would both be 2. So 1 doesn't go there. So 1 does go here, which also means it's this digit, because whatever this digit was going here. And that means that it's relatively straightforward. But that question about where 1 is in row 5 didn't occur to me. That makes these 2 2s and that a 4. Now, that's not 4. Now, we must have something going, I don't know. Now I'm scared that doesn't actually move us forward. That would be horrific. 6 9 1 4 2. That's either 5 8, in which case this is 3 7 and that's 4, or this is 3 7, in which case that's 5 8. So these two are a 4 and a 3 between them. That's very weird, but it is right. It's just it's hard to see. So that's a 3 4 pair. Is that any help? 3 4 2 1. No, it's not. But if this is a 3, that's now a 4, and this is a 7. If this is a 3, that could be a 5, and that could be an 8. And that would fit okay here. This can't be a 3 anymore, because that can't be a 6. This is at least a 3. That's not interesting. Okay, I was wrong in my last supposition that once we got one other deduction we'd be flying. That's been wrong before as a guess. Right, this is either 3 5 8. Oh, this can't be 4. How have I ever left that possibility in? If that's what you've been shouting, you're absolutely right, and I'm a muppet. That has been available ever since that was a 6 because of this cell. Oh, it's hopeless sometimes, isn't it? I don't get better, I just get worse. Anyway, now we are rocking and rolling. This has to be right, I think. I really hope I haven't made a mistake there somewhere. I feel like I might have, because that's been so obvious, it's embarrassing. But we shall carry on regardless. I don't know. I don't think there's a mistake. I don't think any actual individual thing is a mistake. I just worry that my not spotting that for so long is either, you know, evidence of a poorly functioning mind, or I've misremembered something. Oh, there's a 4 up there by Sudoku now. Is that really going to be the next place? I don't think so. I don't know quite where we are going next. So this is 3 5 6 or 7. This is therefore 5 7, which it can't be, 8 or 9, so that can't be 5. This is 1 6 or 9. We know that 7 isn't allowed to sit in this box. Nor was 5, actually. In fact, 5 and 7 can't sit there on that X for the same sorts of reasons. So they're a pair here. That's quite interesting. These are now selected from 4 6 9. So what's that going to do for this X? If that was 4 and 6, well, this could have been 8 and 3, but it's got a 2 in it. Oh, it could be 2 and 3. In fact, it's got to be. If that's 4 and 6, the product is 12, and that's 2 and 3. If that's 4 and 9, 9 and 18 and 27 won't work. There's no other way. There is no way. That is 4 6, and that is 2 3, and this is 9. That's a surprising breakthrough. 4 6 2 3 9. This is 1 or 8. Now, 5, 7 there. 3 is definitely in one of these cells. I keep expecting it to open up a bit and not getting that. 6, 1. This can't be 1, 5, 6, 2, 4, or 9. Well, it's got to be less than that. So it's got to be a 3. Right, this can't be 6 anymore, but it could still be 4 or 7. So there's definitely a 4 in one of those cells now, and there's definitely a 4 in one of those, therefore. That can't be 3 anymore. So this is getting quite high, pushing that even higher. Oh, there's a 4 there. That's really very obvious. 7, 4, that fixes this. 6, 4, and 3 there, 2 there to make the 12 work. Now we've got a 3 in one of those cells. That's become a 6 by Sudoku. That's an 8. You see, I think I've fried my brain doing the earlier stuff, and now I can't even see basics. Never mind. We're trogging on. 1, 2, and 6 left in column 4. I feel like this might be doable now. But actually, 3, 6, 2, 9 would still work there. Except we can't have 9 in it, because 9 is over here somewhere along with 6. 2, 4, 5, 7, 9, 6. So this is 1, 3, or 8. Now, this X might be resolvable now. 8 there is impossible, because 48 is a ludicrous sum, and 16 can't be done. So this is a 1, 3 pair. One of these is definitely a 2, so it can't be 1 times 2. It must be 3 times 2 is 6, and 1 times 6. So I don't know which way round they go, but I know that's a 2, 6 pair. And this is a 1 at the top, and that's not a 1. 1, 4, 2, 7, 3. Now, these can't be 1, 2, or 4. They're either 3, 5 or 3, 6. And that can't be 8. So that's a 9. It's 3, 6 up there. That's 5 or 8. Still 3, 8, 6, 2, 4. 1 is placed there. One of these is a 9. That 1 comes out of that cell, which is quite a big number now. This can't be 6. 7 is in 1. In fact, that can't be 1. The 1 in row 3 is now here. That's 5 or 7. This group is ascertained as 6, 8, 9. I've got a 6, 9 pair in this row, surprisingly. But it's nice. 1, 3, and 7. That is 3 or 7. The difference between those is not 1 and 7, 6. So it's either 1, it's not 1 and 3, 2. So it's 3 and 7 giving 4 there. Okay, well, I like that that comes together. This must be a naked single now. 5. That is 9 and 7. Okay, that's not 9. That's now 9. This is known. This is 8. This pair, 4 plus 3 or 5, got to be 3. That's a 7. I don't think I'm going to need to work out this X if I get lucky. I probably won't. I mean, Kenneth's dad wouldn't have put it in if I didn't need to, I doubt. 4 and 9 there. In fact, we know the order. 9, 4. That gives me... It doesn't give me 9 there. It gives me the 5, 7 pair. Well, I did know 5 wasn't allowed to be on this anyway. I am going to have to do... No, I can do this. No, I still can't do this X. That's very weird. 3, that's 1 or 6. I am going to have to do this X, of course, and really shouldn't be surprised by that. So, 3 times 2, that will work with 1 and 6. 3 times 6 won't work, since that can't be a 2. So 3 times 2 is 6 times 1, and there we go. That's going to finish us off. Six, 2, 1, and a 3. And there we go. What a lovely puzzle spread. It's good stuff, that, isn't it? That's really interesting. Is it a bit mathsy? I don't think really. It's the most basic times table stuff. I think it's just very clever. And you can see the Phistomefel inspiration as well. Really good stuff from Kenneth's dad, as we've come to expect. And as usual, we get to put really good stuff on the channel. I do hope you'll join us for more of it tomorrow. It's an absolute pleasure to bring these incredible works of art to you. Thanks for watching, and bye for now.